At this lab station, we're going to use evaporation and crystallization. So I have an evaporating dish here. You'll notice it's made out of ceramic. You can heat glass beakers on a hot plate, but you can't heat them until they're completely dry, because then they could crack. So the ceramic can withstand that heat. To that, I'm going to add a pipette full of salt water. You can see that that salt water is a homogeneous solution. It all looks the same. That salt is evenly mixed in with the water. And now I'm going to turn on the hot plate and crank up the heat. You can see here as the water evaporates, the salt water gets more and more concentrated, and eventually the salt is so concentrated that it precipitates out of the solution or crystallizes out of the solution. So you can see there's some salt forming on the sides here. We just want to be careful as we get down towards the end. It might start bubbling and spattering salt everywhere. So I'm going to have my tongs ready to go so I can take it off the hot plate. You would never want to do this with a beaker because as it completely dries out, it's going to get really hot, and that would probably crack the glassware. All right, I'm going to go ahead and take this off the hot plate. Now if we look down in here, you can see it's the salt that was left behind. So then if we look over here, we used high heat. And you can see we got very similar results here. If we wouldn't have the hot plate on high, but maybe just on medium heat, it would do the same thing, but you'll notice that we get better crystals forming because if we allow those ions to connect together and attract slowly, we get a better crystal pattern. And under very low heat, you can see how big some of those crystals are. So obviously high heat is the fastest method, but we'll get crystals that aren't quite as nice, and under low heat we get much nicer crystal patterns.